Hello everyone, welcome back to the channel. I am Kagasek and this is episode 3 of our ethical hacking series. If you have been here before, you know the vibe. We build strong foundations, we stay ethical, and yes, we have a bit of fun along the way. Today's a monster of an episode. We are doing the networking fundamentals, the stuff every hacker must know. I mean must. If you skip this, you are basically a pilot who never learned how to read instruments. Dramatic, maybe accurate, absolutely. Before we jump in, quick but serious reminder, everything I explain is for learning, defense, and authorized testing only. Don't go poking public systems you don't own. Run demos in your own isolated lab, VirtualBox, VMs, or a sandbox network. If you skip that, I can't help you if trouble follows. Okay? What is networking? Let's start at the beginning. What is networking? Networking, in the simplest human terms, is how devices talk to each other. Computers don't gossip over chai and biscuits. They exchange packets using agreed upon rules called protocols. Those protocols are the languages and manners of the digital world. I like a postal analogy. Imagine a city of house. Each house is a device. If you want to send a letter, that letter needs an address. The post office figures out the best route. The mailman follows the rules. He can't deliver to someone without ID. Maybe some streets are closed and sometimes the mail gets delayed. Replace houses with devices, letters with packets, the post office with the routers, and the rules with TCP or IP. And you have basically got networking. Why does a hacker care? Because hacking is not magic, it's manipulation of communications. If you want to intercept, analyze, reroute, or protect information, you must first understand how that information moves. Networking knowledge turns a blind guess into a targeted, precise action. A friend once fought a weird outage. Apps crashed randomly, everyone blamed the code. Turned out a misconfigured router was silently dropping the packets at high load. Fix the router, fix the app. That's networking for you. Invisible, fundamental, and often the real culprit. IP addresses, the digital postcode. IP address is the core identifiers. Every device needs an IP to send or receive packets. Think of IPs like postal codes or GPS coordinates for your device. There are two major types, IPv4 and IPv6. IPv4 uses dotted decimal like 192.168.1.1 and it served us for decades, but it's limited about 4.3 billion addresses, which sounded huge in the 80s but is tiny now. IPv6 is the modern replacement, long hexadecimal strings like shown on screen. It gives us a practically endless address space. Public versus private IPs. A public IP is reachable on the internet, it's your device billboard. A private IP is internal, your home Wi-Fi, assigns addresses like 192.168.x.x or 10.x.x. Routers and net sit between private networks and the public internet and translate addresses. Hackers pay a lot of attention to IPs because they map the landscape. Knowing an IP tells you location, roughly, the hosting provider, sometimes the owner, and where to aim the recon. That's why anonymization tools exist to hide your real IP when you are doing legitimate research or testing. If you are doing a demo in your lab, showing IP address is a nice visual. It shows your IP interfaces and state. But remember, only show or scan IPs in the network you control or have a permission to test. Now MAC addresses. They are called as hardware tattoos. While IPs can change when you move networks, the MAC address, media access control addresses, is typically burned into the network interface card. It is formatted like as shown in screen. MAC addresses operate at the data link layer. They are used for local delivery on the same broadcast domain. Routers use IPs to move packets between networks, but switches and NICs use MACs to get frames across the local network. From a hacker's perspective, MACs matter for a few reasons. First, network controls sometimes whitelist or blacklist MACs. Router logs often show MACs for connected devices. MAC spoofing. Pretending to have another device's MAC can be used for privacy testing or bypassing lax filters. Only spoof in your own lab or when authorized. If an IP is current mailing address, a MAC is your device tattoo. It rarely changes, but you can paint over it. In the digital world, that's spoofing. Now, ports and protocols, doors and languages. Now we enter the rabbit hole of ports and protocols. Imagine your device as an apartment building with 65,535 ports. Yes, that's how many ports you have. Each door corresponds to a service listening for connections like web servers, mail servers, SSH, FTP, and so on. Some common doors or ports you will hear are 80 HTTP, 443 is HTTPS, 22 is SSH, port 21 is FTP, and port 25 is SMTP. Protocols are the languages used across these doors. Two big transport protocols are TCP and UDP. TCP is reliable and ordered. Imagine sending a registered parcel. It's tracked, delivered in order, and requires acknowledgement. TCP ensures every packet arrives intact and in sequence. That reliability comes at a cost, overhead, and latency. UDP is lightweight and fast. Think of it as sending a postcard with no tracking, often used for streaming. DNS queries and VoIP where speed matters more than guaranteed delivery. From a hacker's perspective, ports tell you what services are available. Open ports means services are listening. Closed ports means nothing is listening. A port scan maps the doors, this is huge. Probing someone else's system without permission is illegal in many places. Always stay in your own lab. Port scanning is like door-to-door charity workers checking which houses light up. It's persistent, mildly annoying to neighbors, and sometimes you find the one house with the cookies. Now, subnetting, efficient targeting method. Subnetting is the practice of dividing a larger network into smaller, manageable networks. CIDR notation like /24 helps communicate how big subnet is. For example, as shown on screen, includes addresses from 192.168.1.0 to 192.168.1.255. This includes 256 addresses. /16 is bigger and /32 is a single IP. Why should we care? Efficiency. If you are doing reconnaissance in a corporate environment with permission, scanning the entire internet is wasteful. Subnetting lets you focus on a neighborhood where targets live. If you find a vulnerable host at 192.168.1.50 within /24, you know the other 255 addresses are likely similar devices or services. Subnetting also ties into network design and security. Segmentation limits blast radius. If a subnet contains critical servers, segment it from general user traffic. Subnets are neighborhoods. When one house has a bakery, it's useful to know the nearby houses likely get deliveries from the same supplier. Next is DNS, the Internet's phone book. DNS, meaning domain name system, is a deceptively simple but critical component. Humans type friendly names like example.com, but computers route to numbers like IPs. DNS maps names to IPs. It's a hierarchical distributed database. Important DNS records are A. Maps a domain to an IPv4 address. AAAA maps to IPv6. MX mail servers. CNAME aliases. TXT arbitrary taxes. DNS is a valuable for reconnaissance. Querying DNS reveals subdomains, mail servers, and sometimes infrastructure hints. Tools like Dig and NSLOOKUP help you query records, but again, be careful. Some DNS lookup patterns might flag your activity if you go wide. DNS attacks. The classics are spoofing and poisoning. If you can hijack DNS responses or provide fake records, user can be redirected to malicious sites. That's why DNS security matters. DNS secure resolvers and proper caching policies help protect users. DNS is your phone book. If an attacker rewrites it, your calls go to wrong person. Imagine calling your bank and being connected to a scammer because the phone book was poisoned. Terrifying, no? OSI model. The 7-layer map. The OSI model is the classic framework that separates networking into 7 layers. People often complain it's academic, but it's an excellent way to reason about where things happen and where attacks target. First, physical, layer 1. Cables, radio waves, physical tampering, signal jamming. If you have a physical access, you win many battles. Second is data link, layer 2. MAC addresses, switches. Attacks are ARP spoofing, MAC flooding. This let you intercept or confuse local traffic. Third is network, layer 3. IP routing, tools like traceroute, routing table analysis. If you control routing, you can redirect traffic. Fourth is transport, layer 4. TCP or UDP. Think sessions, ports, and reliability mechanics. Many exploitation techniques leverage transport behaviors. Fifth is session, managing sessions and dialogues. Attacks like session hijacking and replay attacks happen on this. Sixth is presentation, encryption, byte ordering, attacks like SSL stripping, downgrade attacks. This layer deals with how data looks. And last, seventh is web browsers, email clients, and APIs. This is where the users live. SQLi, XSS, buffer overflows, and other application level attacks happen. Why this matters? When you find a problem, map it to the OSI layer. That gives you the right tools and mindset to analyze and fix it. The OSI model is like an onion. Everyone wants to peel it, but it may make you cry. Also, like any good pastry, understanding all layers make it taste better. Essential tools and how to use them ethically. Now let's talk about the tools every beginner must know. At a conceptual level and with the safe demo suggestions, these are your senses. They let you see if a device is alive, how traffic flows, and what services are running. Use them only on your own machines or with explicit permissions. First is ping, the first hello. It sends echo request and waits for replies. If a host replies, it's alive. Use it to verify basic connectivity. Show ping to your gateway in your lab to illustrate round trip time. This might be your homework. Second is traceroute. This maps the path your packets take to reach a destination. Great for visualizing the network path and spotting bottlenecks or routing quicks. Demo idea is traceroute between two virtual machines in the same virtual network versus to an external host. Only do this if you are allowed. Third is netstate. Shows active connections and listening ports on your machine. It helps you see which services are talking and which ports are open locally. You can run netstate on a virtual machine with a simple web server to show the listening port. Fourth is Nmap, the reconnaissance Swiss army knife. It discovers hosts, finds open port, and can fingerprint services. Use it wisely. Scanning other people's network without permission is illegal. Rather than listing flags, describe what a scan reveals. Host up or down ports, open or closed, service names, version. This is your homework. And last, Wireshark. Packet capture and deep analysis. It's like having X-ray vision for networks. Use it to inspect traffic, view protocols in detail, and troubleshoot. Demo idea is capture a few seconds of HTTP traffic on your lab to show request or response pairs. Filter by IP or protocol to simplify the view. Run all scans and captures only in your lab or on systems you own. Don't point these tools at random public servers. You will be responsible for what you do. We have covered a lot: what networking is, IPs and MACs, ports and protocols, subnetting, DNS, the OSI model, and essential tools. That's the foundation every ethical hacker needs to speak intelligently about networks. Before we close, A couple of practical learning tips. Build a small lab. Two virtual machines, a virtual router, and isolated networking are enough to practice safely. Use VMware, or cloud labs that explicitly allow testing. Take notes as you run commands. The outputs tell you stories. Learn how Nmap output is structured, what a Wireshark packet looks like, and how traceroute reveals paths. Ethical hacking is as much about documentation and reporting as about discovering issues. We will deep dive into TCP versus UDP. We will dissect packets, headers, explain sequence numbers and acknowledgements, and show safe demos of traffic analysis in closed lab. It's the juicy technical stuff that makes networking practical and hacker level powerful. Networking is like a relationship. It's complicated, needs boundaries, and communication problems caused most breakup. Keep your connections healthy. Thanks for sticking through this long one. If you enjoyed the depth, smash that like button, subscribe, and leave a comment about which part you want me to demo next in lab. See you in the episode 4. And remember, learn responsibly, test ethically, and always keep your lab air gap from the internet unless you own what you are doing.